In this video, I will talk about instrumental variables in Stata. Before you watch this video, please make sure that you have watched my other video called Instrumental Variables. So let's go ahead and get started. I have opened up the Stata program here, and I have already highlighted it and executed it, and this is the output here. So for this example, we would be using the dataset MROZ.dta. And in order to use this dataset, you will need to change where the dataset is stored here on your computer to point to the path of this dataset. So today we will talk about instrumental variables, and the outline of this presentation would be to talk about the IV estimation and then the two-stage least squares estimation, both for simple and multiple regressions. And then we will finish with testing for endogeneity. So we would be reading up this data set, MROZ.dta, and this is a data set on wages for working women. And so in order to proceed, we would only keep the working women here. So we would have keep if in labor force equals 1, meaning only the working women. And so let's describe, summarize, and list the data. Here we would have log wage as being our dependent variable. Education would be potentially our endogenous variable, and we would have experience square as independent variables that are exogenous, and father's education and mother's education would be instruments. So let's go ahead and first of all describe the data. As we're describing the data, our dependent variable is log of wage. Education is years of schooling. Experience and experience square, again, father's years of schooling and mother's years of schooling. So uh, again, education would be our endogenous variable. Experience and experience square would be our exogenous variables. And father's education and mother's education would be our instruments. To summarize the data, we're using the command summarize, and we're listing all the variables. And these are the mean, standard deviation, min and max of the of the data. So to notice here, on average, we have about 12.6 years of education. And the average for the father's education, mother's education is about 8 or 9 years here, and 9.5 years for the mother's education. Here is how the first few observations of the data are looking like. So we're going to list all of the variables that we're going to be using in 110. So the first 10 observations of this, and this is how the data looks like. Okay, so the first model that we would be estimating is a simple regression model where we have regression, reg of log of wage on education, and here we're displaying underscore B of education. This is basically picking up the coefficient on education. So here we have regression of log of wage on education, and these are the results that we have here. Notice that the coefficient of education is 10.8. So how we are going to interpret it is that for one additional year of education, we have 10.8% higher wages for women. So this is the or less estimate. And because the education is potentially endogenous, we have that this coefficient here may be biased. In other words, it may be picking up influence from other variables that are unobserved then in the error term. So here, if we want to just display this OLS coefficient, we see that this is basically the same coefficient. And another thing to notice here is that we have a coefficient that is actually significantly different from 0. So again, this is the OLS estimation of the of this regression model. Now, how we're going to do an IV estimation in the case of where we have one endogenous variable and one instrument. So here the dependent variable would be y, the endogenous variable would be x, and the instrument would be z. So an OLS coefficient has this formula. It's the summation of x minus x bar times y minus y bar divided by the summation of x times x minus x bar times x minus x bar. What we're seeing here is that this is actually the formula for the covariance of x and y divided by the covariance of x and x, which is basically the variance of x. So that is the OLS coefficient formula. And basically, we have the covariance of x and y divided by the variance of x. Now, if we have z, which is an instrument, here's the coefficient for the instrumental variable estimation. Here we would have z minus z bar times y minus y bar divided by the summation of z minus z bar times x minus x bar. So here we have the covariance of z and y divided by the covariance of z and x. That is the formula for the IV coefficient. So let's go ahead and apply these two formulas and calculate the coefficients. The first thing we're going to be doing is calculating the means using the eGenerate command. So here we're going to have the mean of the father's education, the mean of education, and the mean of log of wage. And we would be calculating the OLS coefficient by just taking the difference of the education minus mean education and then log wage minus mean of log wage. And for the denominator, we have education minus mean education times education minus mean education. And if we divide the numerator by the denominator, basically this would be the coefficient here. And if we're displaying this coefficient, remember this coefficient here, 10.8, we should be getting exactly the same coefficient. And so here's the how we calculated the OLS coefficient, and notice that this is exactly the same coefficient that we have above. Whether we estimate a regression or we use the formula for the OLS coefficient, which is the covariance of x and y divided by the variance of x, it would be the same result. Now, for the IV coefficient on education, what we have in the numerator is the covariance of father's education and log wage. So basically the covariance of the instrument and the dependent variable. And in the denominator, we have the covariance of the instrument and the endogenous variable. So basically the covariance of father's education and education. And then we are basically summing up the numerator, denominator, dividing them by each other, and this is how we are going to be calculating the coefficient using the IV approach. So now notice that using this approach we get the coefficient, which is 0.059. So how we're going to interpret this is that for each additional year of education, now we have a much lower effect, which is um, 5.9% increase in wages. So we see that if we're using the IV formula, we are actually finding a lower effect of education on wages. So this is one way using the IV estimation to find coefficients. Let's now talk about the two-stage least squares. So the two-stage least squares, when we have a simple regression with only one independent variable, let's start with the OLS estimation. So we have regression of log of wage on education. If we ignore that we have endogeneity, these are going to be the results. And this is the coefficient that we talked about before. Now, how we do a two-stage least squares estimation, this is the shortcut formula for that. So we have IV regression, and here we have log of wage regressed on education. But here, education equals father's education. If we put that in parentheses, this means that this is the first stage of the two-stage least squares. We're going to be regressing education on father's education, picking up the education hat, which is the predicted values for education, and then regressing log of wage on education hat. Comma first just means that the output is going to show the first stage results, which is this equation here. And if you don't want to have these results, then you don't need to include comma first. Okay, so when we estimate the two-stage least squares and we include comma first, these are the first stage results that are shown, and these are the second stage results. So what we have at this first stage regression is we have education, which is the endogenous variable, regressed on father's education, which is the instrument. So notice that here we have a coefficient of 0.26, and this is basically a significant coefficient. So that's good because it means that we have a instrument that satisfies the property of a good instrument, which is to have a relationship with the endogenous variable here. The other thing to notice here is that the R square here is 0.17, so it's not a very high R square here. So the relationship between father's education and education is not very strong, but there is a significant relationship. So now, from this first stage, what we're going to do is calculate education hat, which is the predicted values. And then in the second stage of the two-stage least squares regression, we would be regressing log of age on education hat. This education hat here is the predicted values coming from this regression here. So even though Stata says education, it's actually education hat that is in here. And so these are the predicted values from the first stage, and this is the coefficient that we have here. So notice that this coefficient 0.059, that is actually exactly the same coefficient that we found above for the IV estimate that we had before. And how we're going to interpret it again is that for each additional year of education, we have 5.9% increase in wages for women. Now, another thing to notice here is that these standard errors here are much larger than the standard error. So this is the 0.03. It's much higher than the standard error right here, which is 0.01 for the OLS estimation. And the reason for that is that the variance here is basically this variance if you divide it by this r squared here. And because we have an r squared of less than 1, that's what actually inflates these the variance or the standard error of these coefficients, and we find that they're actually less significant. Okay, so this is how we calculate the two-stage least squares. Now, the easiest way is just to run this line here, and that would basically be estimating the two-stage least squares. Now, if we want to do it slowly, here's how we can do it slowly. Those data could just gives you the shortcut using these commands here. So in order to run the first stage, what we need to do is regress the endogenous variable education on the instrument father's education. So we are doing regression of education on father's education. So I'm repeating what we did above. So this is the first stage, regression of education on father's education, education on father's education. So this is the coefficient. Again, it's significant, and this is the R square from this regression. If we're displaying the R square, that's what we're getting here, 0.17, same as this R square here. So we're displaying E of R square. This is the internal statistics that are being stored in Stata. So now we can get the predicted values for education hat here. And so we're going to be doing predict. I'm going to call this new variable education hat, comma xb. xb gives the fitted values or the predicted values. And now let's basically compare education with education hat. So if we're looking into, if we're listing education, father's education, education hat, the first 10 observations, this is what we're finding here. So notice this is the original variable of education that is endogenous. And here, the father's education, this is the instrument, and the instrument is exogenous variable. Now, if we have education hat, this variable is only based on the father's education. It's coming from this equation here, regression of education on father's education. When we get the predicted values from here, education hat, it only depends now on father's education. And so you see like how when father's education is 7, these numbers are the same. When it's 14, this is a different number. And when it's 3, it's a different number because it's only based on the father's education. Now, this education hat is a little bit different than the actual value. And here is only the exogenous part of education that is based on father's education. What we're doing here is actually the endogenous part from this regression that we have here is left in the residual, and I will talk about this later on when we test for endogeneity. But here we have education hat only carrying the exogenous information that's coming from father's education. Now, in order to run the second stage for the two-stage least squares, we would be replacing education with the predicted value education hat here. So notice that we have almost like the original equation that we have here. However, education here is replaced with the education hat. And so this is the second stage that we're going to be running here. You see that this is the coefficient, which is the correct coefficient, but the standard errors are not correct when we are doing it the slow way like this. So that's why we need to be using this command that we have here. But I'm showing you that you can estimate these things in a slow way. Okay, so this is how to do two-stage least squares when we have one independent variable that is endogenous and one instrument, which is father's education. Now, let's talk about how to do two-stage least squares when we have multiple regression model with several independent variables and two instruments. So here we would be having the multiple regression model of log wage on education, experience, and experience square. So if we're just running an OLS regression, this is the results that we're going to have. And here notice that this coefficient is 0.107. So for each additional year of education, wages increased by 10.7%. And we see that we have a bit larger effect again. Which may be due to endogeneity. So to do a two-stage least squares in a multiple regression, here we have IV reg. So instead of reg, we're calling IV reg. Log of wage is our dependent variable. And here, what these parentheses are showing is this is the first stage equation for the endogenous variable. So here we have education. And here we have equals father's education and mother's education are now two instruments for education. So you have two instruments for one independent variable. And these are the exogenous variables that we have here. Comma first shows the results from the first stage. And this is what we get here. So the first stage regression is we're regressing education now, which is our endogenous variable, on experience and experience square. These are actually the two exogenous variables from our original regression here. So because they're exogenous, we can also put them in this first stage here. And education for the father and for the mother, these are the two instruments. And again, we're finding that these coefficients here are significantly different from 0, which is good because we have a relationship between the instruments and the endogenous variable. We have these R square again being rather low at 0.21. Okay, so now from here, we're getting the education hat, the predicted values of education. And when we're running the second stage of the two-stage least squares, here we have log wage of education, experience, and experience square. And Stata is making it look like that's education, but actually this is education hat. These are the predicted values from this first stage here that we have. So here we have education hat, and notice that this coefficient again is lower than the 10.7% that we had before. Here's 6.1%. So for each additional year of education, we have 6.1% increase in wages. And this coefficient again is a little bit less significant than the all less coefficient that we had above. Um, so that's how two-stage least squares is done. Now, using the Stata commands for two-stage least squares. Now, we can also do it the slow way, which is in the first stage, we would be regressing education on the two exogenous variables and two instruments. And this is the first stage. And again, we're getting the same results as above. So this is the first stage estimation of education on all the exogenous variables and the instruments. Again, we're seeing significant coefficients here. Now, we can test whether the education and father's education and mother's education is correlated. As we can tell, these two coefficients here, I'm looking at the p-values, are actually significant individually. If we do an F-test for them, which is test father's education and mother's education, we're basically testing if these two coefficients are jointly significantly different from zero, and this is the p-value for this test. So we're concluding that actually these coefficients are jointly significantly different from zero. So we do have a correlation between father's education and mother's education with education. Now, let's get the predicted values. I will call these education hat 1 to distinguish those from above, comma xb is getting the predicted values. So from this regression here, these are the education hat. These are these predicted values here. So now going back into the second stage, we have a regression of log wage. And notice that everything else is the same as this regression here, only that education is replaced with this education hat 1, the predicted values from the first stage. And these are the results that we get here. Again, the coefficients are the same as we have before, but these standard errors need a little bit more correction before they're being reported. Okay, so the final thing that we're going to do here is we're going to test for endogeneity. And the way to test for endogeneity starts with what we call here the structural equation, which is the dependent variable, the endogenous variable, and two exogenous variables that we have. Now, what we are going to be doing here is estimating the reduced form model for education. So this is the same as the first stage of the two-stage least squares. Here we have regression of education, experience square, father's education, and mother's education. So if you notice, actually, this is exactly the same as the first stage for the two-stage least squares. Exactly the same, except instead of getting the predicted values from here, you see like how this is comma xb and that's education hat for the predicted values. What we're going to be doing is we're going to be predicting the residuals here. And so comma residual is going to pick up the residual here instead of the fitted values, so the predicted values. And so now once we have this residual, what we're going to do is we're going to go back into the structural equation that we have here, and we would be putting the residual in here. And now how we're going to test for endogeneity is if this coefficient here on the residual is significantly different from zero, we will have that the education is endogenous. And if it's not, then we would say that it's exogenous. And the reason for that is the following. Because when we have the first stage, for the first stage least squares, for the two-stage least squares, what we are going to be doing here is when we get the education had the predicted values, that is only the exogenous information. So if we actually have the residual here, the endogenous information is left in it. So if the coefficient here on the residual is significant, this means that we would have some endogeneity left into this residual. And that's basically what this test is about. So if we run this now, this is the same as the first stage least squares. That's the reduced form model for education. And again, instead of getting the predicted values here, we would be getting the residual. And now we're going to be putting this residual back into the model here, into the structural model. And we're going to be looking at the coefficient on this residual here. And what we're going to find is that this coefficient is significant at the 10%. So therefore, we have that what we're finding here is that um, actually education is endogenous. And so what this test is showing us is that we need to be using instrumental variables and two-stage least squares to correct for this endogeneity and basically use this method. So that was it for instrumental variables. Thank you for watching.